Lazy Beating. Today I am going to demonstrate on photoelectric effect. So let's start with the topic photoelectric effect. Whenever we are having a radiation of high frequency to be incident onto the surface of a metal, this is a metal piece. Onto the surface of this metal piece, we are allowing a high frequency radiation to be incident. Say that it has mu as a frequency of radiation. This is instant. As we know, metal consists of free electrons. It consists of number of electrons with it. Based upon the frequency that has been incident, we have electrons to be ejected from the surface of this metal. These electrons are termed as photoelectrons and the phenomena is called as photoelectric effect. So to give a brief with the definition of photoelectric effect, when a frequency of radiation, when we are saying here frequency of radiation, we can use the word suitable frequency or I can say here high frequency. When a suitable frequency of radiation is made to incident onto the surface of a metal, electrons are ejected from the surface of this metal. These electrons we are going to call them as photoelectric ions and the phenomena is called as photoelectric effect. This phenomena is simply termed as photoelectric effect. Now coming for the next. We are saying here electrons are ejected. So how can we guess with the number of electrons ejected? It depends upon few parameters. So what are they? The ejected electrons emitted depend on intensity of radiation. We are saying a frequency mu, the radiation is instant here. So what is the intensity of the radiation that has been used and what is the frequency of the radiation that has been incident? Because the frequency that we are giving here is your threshold frequency, which will not remain the same for the metal, every metal that we have chosen. And the type of metal that is chosen, because we have few metals to be having high conducting property and few metals will be having lower conductivity property. So based upon the number of free electrons that the metal possesses, we are having their conductivity or ejection of electrons from the metal surface. So when this frequency of radiation is incident, what is the amount of radiation that has been incident? What is the frequency of the radiation that has been incident? And what is the type of metal that has been used? All these parameters will decide how many electrons are ejected from the metal. So, and one more thing is, it also depends upon potential difference, the voltage that is existing between the anode and a cathode. So we will just to have this clarity, we will go on with your Hertz experiment. So let's move on with the experiment. The experimental arrangement consists of a metal plate with a cathode and you're also having here anode. I'm saying this is a metal plate. So please consider that this is a plate. And the radiation of high frequency is incident onto this metal plate. This is connected to negative terminal of the battery. And this anode is connected to positive terminal of potential divider by means of a galvanometer and also an ammeter. We will be using in between a galvanometer also because we need to measure here angle of deflection and how much amount of current is passing, for which you have a galvanometer and ammeter is connected to a potential divider. So I'm having here this one which is connected to battery. Now, when the frequency is instant onto this metal plate, the electrons are ejected, and then when these electrons are flowing, the amount of current is measured with the help of your ammeter. Now, we are having here cathode and anode. These are the nothing but your A and B. The difference between the potential difference between this anode and cathode also decides as how much or how many electrons are ejected from the surface of the metal. So now the second thing is, we are saying here the radiation is instant onto the surface of the metal. Okay, so H mu is the radiation that has been incident over here. When H mu radiation has been incident here, a part of this energy is used to remove the electron from the surface of metal. This is termed as work function of the energy, complete energy H mu. Part of it is used to remove electron from the surface of metal, which we are calling it as work function. And the remaining is transferred as kinetic energy for the electrons, which are ejected. That is half mv square. This equation is called as Einstein's photoelectric equation, where h mu is the total energy that has been considered, of which W naught is the work function, energy required to remove the electron from the surface of metal, and half mv square is the kinetic energy which is used to or possessed by the electrons that are ejected from the surface of the metal. This equation is called as Einstein's photoelectric equation. So you can expect numericals based upon this Einstein's photoelectric equation, h mu equal to plus W naught plus half mv square. So in brief, first we need to present with the definition of photoelectric effect. When a frequency or a high frequency, or I can also say a suitable frequency, because the frequency changes from metal to metal, it doesn't have the same threshold frequency for every metal. When a suitable frequency is allowed to incident onto the surface of a metal, electrons are ejected from it. Those electrons we are going to call as photoelectrons, and the phenomena is called as photoelectric effect. We are having here electrons to be ejected. So the number of electrons ejected from this metal depend upon intensity of the radiation that has been given here, the frequency of the incident radiation, and the type of metal that has been chosen, and also the potential between or potential difference between the terminals there, that is your anode and cathode. So have a look over your Hertz experiment. This is your cathode, that is nothing but your metal plate is acting as a cathode here. When here you have a radiation to be incident onto this metal plate, electrons are ejected from the metal surface, and these will be constituting the current measured through ammeter. And you are having here this A point A cathode, the negative terminal to be connected to negative terminal of the battery, and you are having this anode plate B to be connected to your potential divider, which is given for your battery. So here the photoelectric effect also depends between the potential difference that is existing between your cathode and anode. Also, we are saying here in the equation h mu equal to W naught plus half mv square, where if h mu is the frequency of incident radiation, W naught amount of work has been done to extract, or I can say remove, an electron from the surface of a metal, which is your work function. And the remaining is given as the kinetic energy of the electrons that have ejected from the surface of metal. This is about a brief description on photoelectric effect. Hope it's clear for you. We will see in the next session about the characteristics, the laws, and the applications of photoelectric effect. Like, subscribe, and share Easy Basic that makes your learning easy. Thank you.